Okay, for those that don't know me already, I'm Bob Brokaw, and today I'm going to try to teach you a bit of what I know about table saws, and hopefully educate a few people so that they can keep connected to the 10 digits that are on the end of your hand there. Okay, a few gee whiz facts about a table saw. A few gee whiz facts on table saws. In a study that I read, there's about 720,000 woodworking related injuries each year. And that number seems to be staying pretty steady. Cycles a little bit according to how much construction is going on. But at any rate, of that 750,000 injuries per year, 42% of them happen at a table saw. That's part of why I'm talking to you today about this stuff. I got to learn about a good amount of that firsthand when I had a nerve injury in my neck that affected my left hand. So the therapist that I was going to had a lot of good information because he was getting about 2 table saw injuries a day walk into his practice. Most of those were contractors, using a job site table saw. Okay, one of the things that you want to do is get to know your saw. Most saws are equipped with a 40-tooth blade. These things are carbide tipped, and they go into a saw like this that takes a 10-inch blade typically. The motors, this particular one has a 1 3/4 horse motor. It is sized that way purposely so that you can run it on a 15 amp circuit. The other sizes that you'll typically run into is 3 horsepower and 5 horsepower. Those are typically the ones that you'd buy at a store like this. They do make them that go higher, but you're not likely to run into them. Okay, the motor rotation is 3,650 RPM. These carbide teeth on the periphery of the blade, when that saw is on, what you're experiencing there is 2,433 teeth per second coming at you, which is kind of an intimidating number. Those teeth are traveling at 1,806 inches per second. And if you guys think your reaction time is good enough to get out of the way of that, you're dreaming. So that's why they came out with a saw like this, a saw stop, because of all those injuries that I quoted previously. What they did is they set this thing up such that even with the lightest of touches against this capacitive charged blade, it would declare a fault, and if the motor is under power at the time that it detects one of those faults, it's going to fire a module in there, or actually release it. This big spring throws this aluminum block up there in the way of the blade, and the blade drops. All of that occurs in about 3 milliseconds. The idea is to get that blade out of the way of whatever it contacted, just in case it turned out to be one of these. I'm going to assume for a moment that this is a saw that is either brand new or its origin is uncertain. In other words, I've not used it before. So one of the things that you want to assume if you're going to use a table saw, they can be extremely accurate, especially if they're properly adjusted. So the things that you want to base it on is this miter slot here. This is one of the few parts on the saw that doesn't move. So you have to start with that as your reference point. First thing that you want to do is make sure that your blade is parallel to this miter slot. Because what can happen is underneath the saw there's a trunnion that handles the raising and lifting of the blade and also the motor and the operation. So the way I typically do in order to adjust a table saw, I got this thing all the way up here, it'll work better. Okay, this dial indicator, what I'm doing is putting the thing on the side of the blade, so I'm using the blade itself as a reference. Now this dial indicator, what I do is I rotate the reference so it's on 0. Okay, that dial indicator is on 0. If this thing is adjusted properly, as I slide this dial indicator back, it will stay on 0. It may wiggle a little bit, but well, as I got off that piece of dust that it was sitting on, it moved. Okay, as I slide that thing back, I get all the way back to the back of the blade, and it is still on 0. So that tells me that the blade is now parallel to that miter slot. Okay, so now we're satisfied that okay.
Bob,
Yes.
since you got the miter gauge in the left-hand slot, would it be best to use to check your parallelness with the same slot that you put the miter gauge in?
I normally don't. This is
Because
just
you're assuming there that those miter gauges are parallel with each other.
true. And we think with a quality saw like this, I don't have anything that will reach across, but in order to accomplish what Dan said there, ideally what you would want to do is take something that is 3/4 of an inch thick and, well, let's see,
No, just put
Sure,
the
if I-
put the gauge in the same slot that the miter gauge is in.
yeah.
Again, with
I was
modern
trying to think of
saws, that should not usually a problem because of the machine technology.
I think I'd be surprised if it is all.
Okay, I've got it set to 0 there, and as I slide it forward, get to the front of the blade, it's still on 0, so I think we can safely assume that these slots are parallel now. Okay, the next thing we're going to do is we've checked to make sure that the blade is parallel to the fence, to the miter slot. Now we have to do the same thing with the fence. I've got the dial indicator against the fence here. This thing is pressed into this slot here, and I'm registered at 0 on this point. I'm going to slide this thing back to see if there is any movement, and you can see that thing moving there. What I'm doing there is we're actually measuring the irregularity of this faceboard that is on the fence.
Each time you stop, it goes back to 0, right?
Well, no, it is 4 thousandths at this point. Okay, all the way from front to rear, looks like I have a reading of 8 thousandths that it's canted out. Now, while we're on that point there, those that are unfamiliar with the principles of a table saw, it's okay to have the fence go out slightly. It's not okay to go the other direction. Because what will wind up happening is you'll be merrily cutting along, and as soon as the piece of material gets in contact with the bottom of the blade, it's gonna start trying to throw that thing at you.
The other thing what happened is the blade will start burning the wood on the back side as it goes to the blade.
That as well.
And you can see that on Rob's saw because it's not correct.
Okay, one of the important points of contact when you're making this measurement here is where the teeth first start performing its cut at the leading edge. And I'm looking at the gauge here, and it looks like about 7 thousandths. So it kind of looks like there might need to be a slight adjustment that might need to be made. One of which might be to swap sides with these two faces to see if this one is flatter. Of course, yep.
I had a terrible problem with this with my grizzly. It was bowed in the middle of the fence real bad. And I ended up buying a piece of extrusion from Peachtree to put it on the face of it,
Mhm.
and it straightened it out really good.
Another technique while I'm thinking of it, I had an issue like this with my saw at home, and what I wound up doing was loosening this board, the fence face, and putting shims behind it. And that did quite a nice job of straightening it out.
Well, question?
Yes?
I know we all want as much precision as possible, but it seems to me, aren't we dealing with an area that we don't really have to worry about? I mean, where does it start to become a reasonable amount of error?
You would be amazed how much that becomes a factor when you get tolerance creep. As you're making a large piece of furniture, you know, something maybe half the size of this saw, if you've got maybe 10 joints in there,
Yeah.
that 3 thousandths will become 30 thousandths.
I'll
by the
give you a
time
good
get to the end.
example of that. I make picture frames a lot,
Yep.
and if you're cutting 45 degrees on the saw and the back is not where the front is, your picture frames no longer match up perfectly. You have to do something to square up the 45. So it shows up microscopic, shows up on picture frame corners.
And where it would become a factor, I know from recent conversations with Jim, he's about to embark on making a roll-top desk. And you can imagine how many joints are in a roll-top desk. You get some of those joints lined up end to end, and you know, a few thousandths is going to make a difference by the time you add them up over the length. I happen to be the one that put this saw together, you know, because we bought this for the club. And I'll pass along a bit of lore that I picked up along the way. When we got this thing all together, we did as best I could of mating up these. I don't know if Buzz can see this joint here in the steel top. This whole top is cast iron, so this is a separate component here. Likewise over on this side. And initially what we had was a catch as we would move the fence from side to side. I think you can see that line right in there. But what we had was a catch that I couldn't seem to get the thing adjusted out. You know, if I got one end right, the other end wasn't right. If I managed to get both of those right, then we had a different problem in the middle. So I was about ready to start talking to David about the fact we needed a couple of new wings, because it was pretty obvious after doing some measurements we had quite a bow in here. Well, then Bob Baxter proceeds to come along. He says, let me show you how to adjust that. And I'm going, okay. So he comes in here with a whole bunch of clamps and all kinds of things and loosened everything up. You know, half took it apart practically. Loosened up all the bolts in there, and he got one edge just absolutely perfect. Bolted that rascal down like you wouldn't believe. Then we went to the middle, you know, got that one from here to here adjusted. And bolted that thing down. And then this end here was sticking up several thousandths at that point. He then proceeded to use a bunch of clamps and a big bar, and he bent this table. And then was when he proceeded to tell me the story that he had, you know, when he was first entering the job market, he worked at a cast iron plant up in Pennsylvania. And he said that's how they used to do it. He said cast iron will not cure, will not stop bending until it's about 7 years old. So if you're getting a new saw, in a lot of cases, this cast iron is not completely cured yet. So it's capable of being bent. Anyway, that's a bit of a story behind buying a new saw, you know, some of the stuff that you might have to cope with there. Okay, we talk about the fence parallel. Another one of my favorite tools on a table saw, and this probably again gets into the category of we never used to do that in the old days. There's this nifty new tool out there called a tilt box. What you wind up doing is I set the thing in the across the table position, zero the thing out so that I now have a good reference to the top of the table. Because the top of the table is where the wood is going to be moving. Then when I place that thing on the blade, and you want to make sure that you're below a tooth, the tooth is not forcing the tilt box out. I don't know if Buzz can catch the display on this thing, but it's reading 90 thousandths at this point, or, yeah, I'm sorry, yeah, 90 thousandths of a degree. So it's almost a degree off. So in order to get a absolutely straight cut, what I just did is I moved the tilt of the blade by almost a degree, and it's now sitting on dead zero at this point. It's usually a good idea to, inside the saw, there will usually be a hard stop, so that when you crank the tilt on the blade, it'll go up against that hard stop, and you'll meet significant resistance when you're trying to move the tilt of the blade. Okay, so that covers blade tilt.
One other thing to watch for is on, if you take that Wixie box, the tilt box,
Yeah.
make sure it's not resting on the insert, because the insert might be off a bit. So it needs to be directly up on the blade and not sitting
Yeah,
down here.
it needs to be suspended by the blade.
Yeah.
Yeah, good point. Okay, while we're on the topic of blade tilt, if you're considering getting a saw, it has been my experience, I am, due to the fact that I've been working with table saws for probably 50 plus years, I am used to the fact that the blade tilts to the left. You want to keep your fence on the right side of a blade that does that. That way, when you go to make a cut and so forth, and you're in a tilted condition, the blade is not going to be forcing against that piece that you've cut.
Or trapping
Yeah, or trapping it is the term I was trying to think of. If you were making that cut on the opposite side, in other words, your fence is over here, your blade is tilted at 45 degrees, you're making a picture frame type cut, you've got that thing just completely trapped. There's a lot of force between the side of that blade and the inside of that 45. And that's a potentially dangerous situation. You got to have an awful lot of control of that board. And while I'm on the topic of control, one of the things that you want to maintain is when you're in a condition where you're cutting against the blade and against the fence, you need to maintain control of that piece. Otherwise, it is gonna find its way into your midsection.
Along those lines, Bob, even if the blade's not tilted, but you're ripping a thin strip off, you
Yep.
need to have that thin strip on the outside
Yep.
of the blade, not trapped between the blade.
Yeah. Okay, we talked about the tilt and some of these other aspects here. One of the last things that you want to do is you're setting up this saw and so forth, and you're getting ready to make your first cut. You want to make sure that the operator's brain is engaged in what's about to happen. If you lose sight and are distracted by what you're about to do here, I mean, you need to make a conscious decision that you're gonna quit fretting about making adjustments to the piece of equipment, and you gotta concentrate on making your cut at this point. Otherwise, that thing can get you. And that's what we're trying to avoid here. So make sure the operator's brain is engaged before you turn the switch on. Okay, the primary thing about a table saw when you're using the fence is it's all about control. When you're cutting something that is a short distance, well, regardless of any distance, but the idea is that you want to maintain control as long as that blade is in contact with a board that is also against the fence. So when you're making a cut, you want to take that cut all the way through before you quit. It's got to be completely clear of the blade. Okay, unlike what I just did here, the goal is that you want to try to keep your hands no closer than 3 inches from the blade. Now, I have seen some teachers and experts and so forth that maintain, at least they used to maintain that if you hook your hand over the fence, that limits your ability to get your fingers in there. But I've noticed that he is no longer teaching that style anymore. Apparently somebody must have got to him. Anyway, it's a good idea to keep your fingers clear of this zero clearance around the saw. And they make these things red for a reason. You know, that's a warning to keep your hands out of that zone. Okay, some of the safety tools that you could use to help you in that regard is I usually make up a push block like this with the handle located where it is. This allows you to push straight down, and by leaning forward on it, you're using a pivot in this region to apply force to the other end. And with sandpaper on the bottom, that allows you to grip it. So that allows you to safely push that thing through, and you're, well clear of that 3-inch limitation that I talked about. Another one of my favorites, since these things came out, is the micro jig gripper system, as they call it.
So,
We'll go on here.
let me ask you this question, Bob, while you're talking about
Yeah.
safety and maintenance. You didn't mention waxing and maintaining the top of the surface? You did not mention waxing and maintaining the top of the surface?
No, I didn't, but it's probably a good point to mention. Rob kind of covered it last week a bit when he was talking about the bandsaws. It's a good idea to keep this top surface just really clean. And then after you clean it thoroughly, then use something like Johnson's paste wax, or some kind of a car wax that's got a good amount of carnauba in it. It'll make that top slick, and it'll make it a lot easier for the wood to glide across the steel which will make it much easier to feed this thing into the blade. Otherwise, if you've got crud on your surface, and that's a technical term, you will be fighting that thing moving across that steel as you try to get the thing through the blade. So that becomes a challenge. Okay, one of my other favorite tools is these grippers, made by Microjig. They sell them out here in the store. You put this thing down on a piece of wood, and those green treads on there actually, grow into the wood a bit. And it does a fantastic job about keeping that thing flat, going through the blade, so it makes it easy to bridge over the top of the blade and complete your cut.
Do you have literally your hand over the blade when you're doing that?
Yes.
Holding the handle can't get any closer.
Yeah, there shouldn't be any problem with that, because what, kind of jumping ahead a little bit here, there's two blade heights to a table saw. You could crank that one up like that, and that height there is what I call the amputation stage. You got way more blade exposed than what needs to be. What you want to do is you want to adjust your blade so that it's no higher than it's just above the surface that you're trying to cut. So what I try to do is I try to get the blade height so that the carbide clears the board. So it's, okay, right about there, the bottom of the carbide tooth is even with the top of the board. So that minimizes the height above the blade.
So not the end, the bottom of the gullet?
Yeah,
but
the bottom of the gullet, is kind of unimportant at this point.
Really the end of the tooth itself.
Yeah, the bottom edge of that carbide tooth, since most blades are carbide these days.
Unless you're cutting something really thick. If you're cutting 2-inch oak, you
Yeah.
want to see the gullet. You need it.
Oh, yeah, in order to clear all of the sawdust that it picks up, yes. Okay, this particular height here is what I refer to as the laceration height. You aren't gonna lose a finger. You're gonna cut it severely if you're on something other than a saw stock, but at least you aren't gonna cut bone. But that height, along with this height difference inside these grippers, allows you to bridge over the top of the blade safely. You can maintain control of the board, you can maintain pressure downwards, and be able to get the thing all the way through without having to change your grip. That's why that's my kind of my favorite when I'm cutting smaller pieces. If you've got a longer piece, you may need 2 of these. I've used that in the past, and also for pieces that are appropriate, this is also a good tool. But if you're dealing with a really long piece, this isn't going to do it either. Okay, lots of questions now. I think Jim was first.
I was just gonna make a comment on the gripper. I just got one,
Yep.
and there's many, many applications for it, but in my opinion, throw the DVD away that comes with it. Because it's old and not that well done. There's a lot better YouTubes out there, and all you
Okay,
have to do is
yep. Generally with these 1 3/4 horse motors, you are probably going to be a lot happier with a thin kerf blade. Some people will argue, and I think this is urban myth more than anything else, some people will argue that the thin kerf blade is going to, when it runs, it'll wobble. I have not found that to be the case, because my saw at home is also a 1 3/4, and I have built plenty of furniture without having to worry about, I think Charlie had a question.
Yeah, one little thing about frippers, they do require maintenance.
Okay?
A little alcohol on that green urethane surface, they get slippery, and here's how you can tell. You turn it over, and it needs to be intensely green. It's got a gray beige film to it. It doesn't take but a few seconds. Wipe it
Okay.
off, let it dry, and then maybe a dry cloth or a paper towel and clean whatever residue may be.
Bob?
Yes, sir.
Another thing about blade that's not cutting well, you gotta make sure it's clean,
Yep.
you gotta make sure it's sharp.
Mm-hmm.
We have a tendency, or at least I have a tendency, to run a blade a lot longer than I should, and it gets dull, or it gets dirty.
Yeah.
How do you know if it's dull? They always feel sharp.
If it's not cutting well, and if it's changing color on the wood, making burn marks and that kind of thing, it's probably dull.
You clean it.
They sell a product out here, you recall the name of that thing, Rob?
Pitch RX.
Yeah, Pitch RX it's called. I've got a small pizza pan at home. I think it's a 12-inch diameter. And I find that to be just perfect for sitting the blade down in there, spraying some of that Pitch RX in there, and it's, just big enough, just deep enough that it works real well for that. Then when I get done soaking it for like an hour on one side, there's enough material in there that I could just flip it over, leave it sit for another hour, then rinse the thing off in water. Okay, while we're on the subject of the dull blades, there is a blade sharpening process in the area that I use at any rate. I think they're over in Dalton, Georgia. I was going to point out is there's several vendors in the area. Since I live in Lilburn, I usually drop mine off at Kentech there. And since Lindsay works at Rockler, they got a pickup location there. But they will send a shuttle vehicle around once a week in the area, pick up blades and drop blades off.
While we're talking about saw blades, I've noticed that, there's a difference between the way a ripping blade and a crosscut blade works. And so, if you're pushing too hard on a lot of ripping, then you just get a blade that's designed for ripping.
Mm-hmm. Since he brought up the topic there, I'll cover it quickly. The normal purpose of a table saw is to do ripping. That was the intended purpose behind it. So that if you can take a long board that you need to be half as wide as it is, the typical blade that you would want to use for such a process would be one that's typically 40 teeth. That's kind of the average blade that you would use for such a purpose. It's ideal for ripping. It's okay for doing crosscut work if you don't have any other type of tool to be able to do it with. Now, this class here, I'm making the assumption that the only tool in your shop, capable of doing much of the way of cutting is a table saw, because that was the way I started out. I didn't have a bandsaw. I didn't have a miter saw, at least not an electric miter saw. And so I figured out ways to safely make cuts with a table saw. And let me pass along a couple of tidbits here before we move on to the next part. What you want to do when you're ready to start making a cut here is hopefully you've had experience with being around somebody else that has used a table saw, and there's a sound that a table saw will make when it makes a cut. You want to have that sound memorized. Sound is a really important part of woodworking, because if it doesn't make that sound when you're making a cut, it's time to stop and rethink what you're about to do. Because you may not be doing something right. So you need to re-examine, what it is. It could be a strange piece of wood that you've never cut before, any number of things like that. The other thing about sound is if you're, you made a few cuts with your table saw and so forth, you start to feel kind of comfortable and all that kind of thing, and then all of a sudden you get in that situation like that, where you've got a pretty small space there, and you're about to turn that table saw on, and you're looking at this thing, and you got this little tingly sensation that's going on in your skull. Listen to it. It's warning you that you're about to do something that may not exactly be safe. So just kind of, let go of everything, shut the machinery off, and stand there and study this thing and go, do I really want to do this? Or is there a better or safer way? So listen to that little tingly sensation that your body is sending you. George brings up an important point. I know I've got it in my notes here somewhere, but I may have skipped it. What he's bringing up there, and we can't get the camera equipment to cooperate here, but there's a switch down here on the front of the saw. Rubbing my hand against there while the display was picking it up.
Is it plugged in?
It's switched off though. Okay, I'm going to pull that switch out as though the saw were operating. What I regularly do with my saw, the blade would be turning at this point. As soon as I get through with the cut, you'll notice how extended I am in that direction. Now is not the time to go hunting for the off switch. Okay? Since my saw and this saw have a very similar type of switch, I've got it memorized where all I do is raise my left leg and hit the off switch and the blade stops. So your saw should be equipped with some type of a switch like that. You want to put it in a place that you can get to when you're in a posture like what I was demonstrating there. And you want to memorize that location mentally so that you can hit that thing to get it off. Okay, let's move on to a couple other things here. As far as the safety devices that are on the saw, one of which that I haven't talked about yet is this riving knife that is here. One of its purposes. Oh, okay. One of the purposes of this riving knife here is when you're making a cut in a trapped situation like this, the riving knife is going to keep the end of that board from swinging around. The point in time where you really want that to happen is when you're right here. You're just about to exit the cut, but you still got a couple of teeth in contact with the front edge of that board. The last thing that you want to have happen is for that board to rotate around and catch the backside of that blade. On the saw stop, this riving knife is removable. When I demonstrate the same thing, when you're in this condition here, and if you did not have control of the end of this board, you'll notice how easy I can move that thing away from the fence. And all it requires is, you already saw me measure that run out there to be about 8/1000ths. I've got at least a 1/16, if not 3/32 right here. What's going to wind up happening is the next time that tooth rotates around, the one that is beveled in that direction, it's gonna catch that board, it's gonna lift it up, and at 102 miles an hour, it's coming at you. Are you prepared to catch it? One last thing on the kickback and so forth that you get, especially with 1/4-inch plywood. You know, when you're cutting like that, you know, up against the fence, and it's trapped without the riving knife on there, it is amazingly easy for that thing to rotate at that point. What happens then is the blade gets a hold of that thing in the back, and it begins rotating like this. That's why you get this circular cut on the bottom, and it's moving it this direction while it's doing it, comes out this way and hits you. Well, that caused a, pretty good amount of subdural hematoma in my case, but that wasn't the end of it. It hit me at that 102 miles an hour that I referred to, and then that caused me to back up enough and bend over, but in the meantime, this thing was still active. All right? I bent over, this thing caught the blade again. I heard this noise that I couldn't quite figure out what it was.
Then it went dark.
But no, it didn't go dark. The next thing I heard was this great big noise behind me. And I'm going, the source of all the noise ought to be up here. What's this noise behind me? That piece of plywood that I had sailed across the room about 30 some odd feet and hit that big roll-up door that's in Rob's shop. I finally figured out that's what it was, and I thought, ooh, I'm glad I wasn't in the way of that. Okay, enough on the stories here.
So, Bob, what is it called? Anti-kickback pole?
Okay,
That's installed in your other part there.
yep. The anti-kickback poles are sometimes used in regular woodworking. It's probably not all that great of a tool. But this blade guard goes on here, and I think there, I was running into something I didn't see. This is the blade guard that would normally go on top of here. As you're taking a board and pushing it through the saw, the blade cover goes out of the way. This anti-kickback pole would normally install back in this region here, and it would go at this kind of an angle. Back in this region here, all these teeth that are on here, so that if you do get an actual kickback, the intent is for those things to keep that thing from coming at you. This is commonly used in construction where you're doing ripping only, and it's usually a through cut that you're making. So by through cut, I'm talking you're cutting this entire thickness of the board. As woodworkers, we frequently do cuts that are not necessarily through. You're getting prepared to do a rabbet or some other cut that is not through. So anyway, that's kind of what the anti-kickback pole and the blade guard do. Most woodworkers that I know of
Take it off.
remove that part and put the riving knife on instead. Okay, when I talked about the sound that your tool is going to make, it's supposed, okay, is plugged in. So what I was doing there was just cleaning up the edge of that piece of wood. Now the intent is there, you can tell by the gauge that it's 2 inches now. Okay, I'm going to come in a 1/4 inch. And my intent here is I'm gonna make a 1/4 inch rabbet on the end of there. Here's another tool that I like to use with the table saw, is a depth gauge. So, okay, I've just zeroed that the way I typically do a 1/4 inch depth cut. Got 250 thousandths of blade exposed. Yep, 1/4 inch. So what I'm going to attempt to do is make a 1/4 inch rabbet. Okay, what I'm doing here is reading the scale so I can figure out how far I have to go in order to achieve a 1/4 inch rabbet. Let's see, I got a number of different things I could use to accomplish this. This would be a case where I'm going to use 2 grippers. Okay, this is a skinny push stick. I use that for 3/4 inch and on up boards. There's your 1/4 inch rabbet. So there's your first step in making one of next week's joints. That's some of the steps that you would go through in doing that. Any questions on what I just did there? Okay. Okay, we've talked about a bunch of safety devices. Showed you about kickback. Okay, we talked about memorizing where the off switch is. Another good idea, since most of us operate in our shops alone. We don't oftentimes have the luxury of having a shop the size of Rob's where you got 4 or 5 people in there at any given time. When you're operating alone, this is your communication with the outside world. You want to have that thing accessible. In the event somebody can't hear you, you got to be able to reach some type of help, even if it involves getting paramedics out there to look after whatever your condition is. Any questions on that? Another thing that you want to have handy, yeah. Number one, you want to have a first aid kit. The second one is know where it is, in case you got to get to it in a hurry. Yeah. Duct tape works. The super glue also works. If you got a bad enough gash that you got to close, I mean, not necessarily a table saw, but most any of our tools are capable of cutting you. You'd be amazed at what damage you could do to yourself with a chisel. I would heartily recommend you stock a first aid kit. What I did when I built this first aid kit for here, these ones that you go out to the store, to the grocery store or the drugstore or something like that, and you buy a pre-assembled first aid kit, about half the stuff in there is worthless. So you're well ahead of the game to just go ahead and get yourself a small tote of some kind and carefully select the supplies that go in it to be appropriate for your shop. Things like gauze, several different kinds of tape, items like Okay, what I wanted to do at this point was show you a different type of miter gauge. The one that comes with the saw, in my estimation, is a miter gauge in name only. Functionality, it leaves a lot to be desired. I much prefer something with a wide body like this. I think Incra also makes one that's similar. You may know others.
Incra is the one I'm familiar with.
Yeah. But anyway, what I prefer to do is I will use one like this. I keep it maybe a 1/4 inch away from the blade. Lock down the sliding mechanism. That way, when you're cutting short pieces off of here, you've still got the miter gauge close enough to the blade that you're maintaining control. The intent is that if you're about to make a crosscut here of some finite length, you want to be able to have control of the board and also have control of the miter gauge. So this thing pins at 90 degrees. So I've got pretty reasonable confidence that this thing is set at 90 degrees, so that when I make a movement in that direction, I've got the fingers pressing against the face of the fence. So I've got control of both. So I've got the miter gauge and the piece of wood. And for good measure, what I did is I took PSA paper and stuck that on the front of the miter gauge. That way it can't slide side to side. If I've got good pressure on that thing, it's near impossible to move that thing.
I use a clamp on mine sometimes.
Yeah. You make a good straight person there, because while I got that thing set up there, if you've got to make a cross cut, on a piece that is this big, let's imagine, if you will, that it's another 4 or 5 inches further out there. You slide this thing back, and you're sizing things up. You let go of this thing, the free end is going to drop down. You think you're all set to go. You go forward some distance, and you run into the front of the saw. What I have done to accommodate that is I take a couple of blocks while the blade is still, or while the piece is still fully engaged on the table. I'll take a couple of blocks like that, clamp it down with one of these speed clamps. That way, when you get off the table, the end of the miter is not going to drop down to be able to catch the saw. That way, when I'm ready to make the cut, I just proceed forward, and I don't have to worry about doing anything unnatural to hold the end of that thing up. Any question on that? Okay, we talked about using the fence for rip cuts. We talked about using the miter gauge for cross cuts. There is a good amount of danger in trying to involve both. You would think on the surface that, okay, I'm ready to make this cut here. Okay, I got good control of this. I got good control of the miter gauge. I'm registered up against the fence. I'm going to cut this way. What's going to happen when I get to the end of that cut? This board is now trapped between the blade and the fence. I don't have control over this one. That thing is going to take its 102-mile-an-hour trip at me. if you're forced or faced with having to make cuts similar to this, there's a much safer way to do it. By taking a block here and another speed clamp. What you want to do is you want to.
Situation you're not using the riving knife?
Riving knife will help some, but even if the riving knife prevents it from moving this way, the blade is still spinning, and it's going to start throwing it straight at you rather than throwing it at you at an angle. So you're still going to get hit with a board. Okay, now that the whole purpose of this is I can now slide this thing up. The idea here is that this is just short of the leading edge of the blade. So it is my registration stop that I line up that way. So that is my spacing. So the distance between the end of this board and the blade is the part that I want to get cut. I now start sliding it through like that. The intent is that I clear this block before the last tooth of the blade clears the board. That way I'm back over here when I'm finally done cutting the board. That way there's, this board is going to jostle out of the way. There's no way that it can get trapped now between the fence and the blade. It's going to get clear of the blade so it loses its, any incentive to be propelled. I think there's one last whiz bang that I wanted to give you guys. I've noticed over the years in here that several of you have mentioned you got this precious piece of wood that you're trying to maintain. Lindsay, can you get me that big long, beside the cabinet?
Johnson.
Yeah, that level. Several of you have indicated you got this precious piece of wood that you're trying to preserve. You can't, it's long, and you can't figure out how to do it properly. And so Buzz can get a shot of it. They will do it this way. What you could do with a big long level like this or something equivalent to it is get a hold of the handholds on the level. Clamp that to the fence. What this basically does is it extends your fence. So you've now got a 6-foot fence. And when you're trying to true up a board that maybe doesn't have a straight edge to it, you've got the full length of the board engaged in the level. And I can tell from this one that this one has a crown in the center. So you want to hold this thing tight against the back edge of the level. Make your through cut here. That way when you get done with the cut, that cut that you just made should be now a straight edge that you can use against your regular fence, or if the level is still there, flip it over, and now you can true up the other edge, and you now got a parallel board to start with. You can then continue on with whatever you're trying to do. So I think with that, I'll declare time on myself.